Hello everyone. In this video, we are going to work on section 8.3, which is about the dot product. So as we have seen the formula in the lecture video, for the first question, it says find A dot B for the following vectors. We see that A is -3 and 3, B is 0.7 and 1.2. So A dot B, according to the formula, would be -3 times 0.7 plus 3 times 1.2. So for the first one, that is -2.1, and the second one, 3.6, and the answer is 1.5. For the second one, as we have seen before, we may like to write it as 3, 2, and -1. These numbers come from the coefficients of I, j, and k. So B will be 4. We don't have any j here. Since j is the unit vector of y-axis, that cannot be 0. The only thing that makes it the term 0, so you don't see any term having j in here, is that the coefficient is 0. So we would say put 0 here and 5 here. Based on these two, either you like to write it in this way or this way. A times B, or A dot B, would be 3 multiplied by 4, which is 12, plus 2 multiplied by 0, which is 0, and -1 times 5, which is -5. So you would have 7 as the result. Number 2 is about finding the angle between these two vectors. So as we have seen before, we have another formula for the product that would be the length of A times length of B times cosine of the angle between them. So in here, we're going to find the angle, but we cannot find the angle directly. First step, we are going to find the cosine of the angle. Based on this equation, that would be A dot B over absolute value of A, absolute value of B. So for the top, we just multiply them together as dot product. That would be A times B. So A dot B. So it will be square root of 3 times 0 plus 1 times 5. And for the bottom one, the length of A is square root of 3 squared plus 1 squared times the second one, which is 0 squared plus 5 squared. So altogether, for the top, we have 5. For the bottom, we have this one is a square root of 4, which is 2. And in here, this is square root of 25, which is 5. So we would have 2 times 5, and we would have 1 over 2, or halves, for the answer. So we have seen so far that cosine of theta is halves. So what is theta? Theta would be cosine inverse of halves, or 0.5, or 1 over 2, which is pi over 3, or 60 degrees. Number 3. It says determine whether A or B are orthogonal, parallel, or neither. So in order to have orthogonal arrows, as we have seen in the lecture, if one of them is like this and the other one is like this, and this angle between them is 90 degree or right angle, it means that when you find A dot B, so we have length of A, length of B, these cannot be 0 because we should have two vectors. But this part, cosine of theta, if theta is 90, would be 0, and the answer would be 0. If we find the dot product of two different vectors and the answer for that is 0, we can conclude that these vectors are orthogonal. So let's find it here. Since we don't have any angles here, we are going to use the other formula, which says -1 times 3 plus 2 times 4 plus 5 times -1. So this one is -5, this one is 8, and this one is -3. Altogether, this is 0. It means that these two vectors are orthogonal. Number 4, for what values of B are the vectors that is given to us orthogonal? So based on the information that we have so far, we know that if we multiply them together and the answer is 0, so those vectors are orthogonal. So we have -6, B, and 2, dot B, B squared, and B. So let's multiply them together. That would be -6B plus B cubed plus 2b. We can simplify this as -4b plus b cubed, and we want this to be 0. So solving this equation means we can factor out b, and we would have -4 plus b squared equals 0. So either the first one is 0, it means b equals 0, or the second one is 0. -4 plus b squared is going to be 0. Add 4 both sides, you would have b squared equals 4. It means b is either positive or -2. So for b equals 0 or plus or minus 2, these two vectors are orthogonal. Number 5, find an equation of the plane through the point that is given to us with normal vector. So since this is the normal vector, the first one is A, the second one is B, and the third one is C, according to the formula. And the point that is given to us, the first one is x sub 0, the second one is y sub 0, and the third one is z sub 0. Following the formula, we would have A, which is 1, times x minus x sub 0, plus B, which is 4, times y minus y sub 0, plus C, which is 1, times z minus z sub 0, equals 0. So we can simplify this to x plus 1 plus 4 times y minus 2 plus z minus 3 equals 0. And it will be x plus 4 times y plus z equals the constants that you see here. 1 minus 2 is -1, and minus 3 would be -4. So we can bring it to the other side, and this is the equation of the plane. Next one is number 6. It says find the scalar and vector projections of B onto A. For vectors A, which is 1 and 2, and B, which is -4 and 1. So let's recall the formulas. We had the formula as component of B onto A, which is the scalar projection, and that is A dot B over length of A. And also we had another formula about vector projections, which is A dot B over length of A times A over length of A, which is the unit circle. So we're going vector. We're going to find these details. First of all, the absolute value of A is square root of 1 squared plus 2 squared, which is square root of 5. And we need to know A dot B. A dot B, based on the information that we have, is 1 times -4, which is -4, plus 2 times 1, which is 2. So the answer would be -2 here. We need to put this into the formulas. For the first one is A dot B, which is -2 over square root of 5. This is the scalar projection or component of B onto A. And the next one, if you pay attention, these two are the same. So the first part is -2 over square root of 5 times A, which is 1 and 2, over length of A, which is square root of 5. So we know that when we multiply them together, we have -2 over 5 times 1 and 2. And the answer would be -2 over 5 and -4 over 5 as the vector projection. We will talk about section 8.4 in the next video.